Hey guys, Mr. Stockton here. So today we're going to talk about Punnett squares and how we can use them to solve genetic problems. So I kind of give you four kind of rules that we'll follow throughout. The first one is you need to figure out how many gametes and what those genotypes of the gametes are going to be. And we use that equation we talked about earlier where we have 2 to the nth power where n is the number of heterozygote traits. So if you had the alleles big G, little g, big R, big Y, little y, we would have 2 heterozygote traits, so we'd have 2 to the second, or 4 possibilities. We could have big G, big R, big Y. We could have big G, big R, little y. We could have little g, big R, big Y, or we could have little g, big R, little y. And so these are the 4 gametes we could make, and then those would go on one side of the Punnett square. So once you have those, you're then going to place them on the different sides of the square that we're going to create. Once that happens, you're going to fill in the grid. This is going to show the genotype. And then once you use the law of dominance that we talked about in the previous, then you'll be able to determine the phenotypes. So we're going to go through some examples and we'll kind of refer back to this so you can see how that works. So the first thing that we need to talk about are the 3 generations. And so here we have the P1 generation. So the P1 generation is usually, if we're talking about Mendelian genetics, is going to be pure breeding. So this is where he made sure that they always had the same genetics, same offspring, always looked the same. Okay, so what you do is if you take 2 P1s and you cross them, you get the F1 generation. And then if you take 2 F1s and cross them, you're going to get the F2 generation. And so this terminology is going to be used throughout when we do these problems. So it's important you understand this terminology. So the first thing we did is we're going to look at some monohybrid crosses. And so what monohybrid crosses are ones where we have just different alleles for a genetic trait. And the great thing about these is it's just a single genetic trait. So let's look at a P1 cross. So if we're looking at, let's say we're looking at height. So Mendel had what he called tall plants, which we're going to go big T, big T, sorry, homozygous then. And he had short P plants, which was the recessive. So we're going to go little t. If you were to cross these, so the first thing we need to do is figure out how many gametes we can make. Well, these can make only one gamete. So it's going to be a big T. These guys can only make one gamete, so it's a little t. And so we set up the square here, and then we fill in the square, so we got big T, little t, or all of the kids that they have, all their offspring, are going to have this big T, little t, or be heterozygote. So we would have 100% big T, little t, or we'd say we have 100% would be tall. So what's the difference here? Well, this right here is the genotypic ratio. This down here is the phenotypic, or the physical trait of that thing. So now we're going to take these offspring, which we call the F1s, and we are going to cross them. And so now we said we're going to take those offsprings we just created. And so those offsprings were a T, big T, little t, crossed with a big T, little t. Okay, we have one heterozygote trait, so we can make 2 options. So this parent could give the big T or the little t. This parent could give the big T or the little t. And that's going to create our Punnett square. Oops. Our square there. Sorry about that. So we could go big T here, because we just dropped down. We could go big T. This one could be the little t. We could go little t on the outside, big T over, little t, little t. And so what we're going to see here is a little bit different. We're going to see what's called a 3-to-1 ratio when we're looking at the phenotype. Okay, so phenotype. And that's going to be 3 tall, 1, 2, and 3, and 1 short. Okay, and this is really important in Mendelian genetics, is this ratio. If we were looking at the genotypic ratio, we would have 25% homozygous dominant, right? Same, big T, big T. We'd have 50% heterozygous, or big T, little t, and we'd have 25% little t, little t. Okay, so we call this an F1 cross because we're taking 2 of the F1 generation and crossing them. And it's in his F1 that he always saw this 3-to-1 phenotypic ratio where we have 3 of the dominants and 1 of the recessive. Okay, so now I'm going to give you a chance to do some practice. Here we're looking at seed color, where big Y is going to be dominant and it's going to be yellow, little y is going to be recessive and it's going to be green. So take a second to do this problem and kind of pause the video, and then I'll help you go through the problem. Okay, so what you first need to do is decide how many gametes this can make. So big Y can only pass on its big Y. Big Y could pass on either the big Y or the little y. So we set up our Punnett square. We're going to get big Y as an option. We're going to get big Y, little y as the second option. So first question is, what is the genotypic ratio? So genotypic, we would have 50%, right? Oops. We would have 50%, or 1 out of 2 is going to be big Y. We're going to have 50% big Y, little y. And how do we get that again? There's 1 out of the 2 is going to be big Y, little y. Okay, then the next part is, what is the phenotypic ratio? Well, each one of these has the big Y, so it's going to be 100% yellow. And so if you crossed 2 yellow seeds, one that's homozygous and one that's heterozygous for seed color, we'd always get this 50-50 genotypic ratio and 100% phenotypic ratio. Okay, so now we're going to look at dihybrid crosses. And a dihybrid cross is when you take any 2 traits that you're looking at. And so typically you're going to take 2 heterozygotes for those 2 traits. So here we're going to look at seed color, big Y, big T, little t for height. So we got seed color, yellow, height, tall, crossed with another heterozygote for those 2 traits. And so what do we get? Well, essentially we have 4 gametes we can make for each one, and so we're going to have a large Punnett square. So the Punnett square looks just like this. And when we do this cross, okay, you're going to get this 9 to 3 to 3 to 1 ratio. And so what does that look like? Well, 9 of these guys should be yellow, since that's the dominant color, and tall, since that's dominant. We should have, so let's go ahead and do that. So we got 1, so big Y and a big T is all we're looking for. 2, 3, 4, big Y, big T. 5, big Y, big T. 6, big Y, big T. 7, 8, and 9 of them. Okay, so then we should have 3 of them that are going to be green or recessive, and 1 dominant trait, which is tall. Okay, so now we're looking for little y's and a big T. So little y's and a big T, we've got 1, 2, and 3. Okay, and then we should have 3 that are yellow and short. So we've got yellow and short, 1, 2, and 3. And then finally we should have 1 right here at the bottom that should be green and short, or both recessive traits. And so we always see this 9, 3, 3 to 1 if we're looking at 2 traits that we're both heterozygote for. Okay, so now we're going to look at test crosses. And test crosses are used to kind of tell us an unknown genotype for a dominant trait by crossing it with a homozygous recessive genotype. And so one problem might read something like this. So is the plant homozygous or heterozygous for seed color? So essentially we know already that if the plant is green, it's got to be recessive and homozygous, right? But what we don't know is if the plant is yellow, if it is a big Y, or a big Y, little y, because these both equal yellow. And so we've got to cross the plant with a green plant to find that. So if we cross plants, green giving little y, let's assume that it's big Y, right? All of their offspring should be big Y, little y, or all of their offspring should be yellow. And so this tells us if all offspring are yellow, we know we have the big Y genotype. The other option would be if we had the big Y, little and little y crossing. Okay, 50% of these offspring are going to be little y, 50% big Y, or we'd have 50% yellow, 50% green. And so this test cross allows us to figure out if we have heterozygous or homozygous for that dominant trait, in this case yellow. Okay, well that is kind of a brief intro to Punnett squares. Thanks for your time.